When Gordon Hayward suffered his injury, his season ended, and the Boston Celtics' hopes for an 18th Larry O'Brien trophy were dealt a massive blow.
But how exactly did this happen, and what can he do to get back on the court? Let's break down the science of Gordon Hayward's injury.
During this play, just over 5 minutes into the game, Hayward executed a backdoor cut and jumps up to receive an alley-oop pass from Kyrie Irving. He collides with LeBron James in midair.
Hayward is knocked backwards and falls awkwardly, landing with all his body weight supported by a leg not yet planted. The force of this fall was enough to break his tibia and dislocate his ankle, even causing him to end up with his foot bent away from his leg at nearly 90 degrees.
Using his recorded measurements of maximum jump height and body weight, it is possible to calculate Hayward's force on his leg.
To help with the calculations, we will go into the ESPN Sports Science Lab to recreate the injury and find out what happened with our state-of-the-art Newtonian physics calculations. To do this, we will need to first find out some information about the circumstances of the fall. When Hayward hits the floor, which according to NBA regulation is a maple hardwood, it yields 3/4 of an inch, or 0.01905 meters. Hayward's maximum vertical height is 34.5 inches, or 0.86 meters. Also, he weighs 211 pounds, or approximately 96 kilograms.
The formula for finding the force of a falling object is F equals 1/2 mv squared over s. This means that the force exerted on the falling object is equal to 1/2 of the mass of what is falling multiplied by the square of the velocity that is falling, divided by the stopping distance.
The velocity Hayward was traveling at is a combination of two things, his acceleration from falling and from the collision with James. His velocity from falling is pretty straightforward. We can use the equation v squared equals v initial squared plus 2ad. He is falling from a height of 0.86 meters at the acceleration of gravity, meaning that his velocity from this is 4.1 meters per second.
LeBron James generates 9,300 watts of power when he jumps. From the previous step, we find that Hayward fell for 0.210 seconds, meaning that the King exerted roughly 44,000 joules of work on G-money, or 50,000 newtons of force. This means that James sent the 96-kilogram Hayward accelerating at 11 meters per second, at the very conservative estimate that 10% of James's total force was exerted onto Hayward.
Combined, this means that Hayward was falling at roughly 15 meters per second, and when plugged back into the original equation, almost 38,000 newtons of force was exerted on Hayward's leg.
To put this into perspective, it normally only requires around 5,000 newtons of force to break an average human's femur, which is thicker than the tibia. Also, when considering that shear forces are more destructive to a bone, that makes it easy to see that Hayward's fall was more than forceful enough to break his tibia.
After Hayward broke his tibia, the only thing that he could do in order to return to the court as soon as possible would be to find out the appropriate course of action to take so that his bone could mend properly. The matter of his dislocated ankle can be relatively easily treated by setting it back to its original position and taking care of it with rest, ice, compression, and elevation. However, his broken tibia is a more serious issue. The Celtics eventually confirmed that Hayward's injury was a tibio-talar fracture dislocation. This is when the joint that connects the tibia and the talus, which is the largest bone in the tarsal region, is moved out of its original position. This usually does not happen without an ankle fracture because of the stability of the joint. According to Jessica Flynn, MD, Hayward will probably have to undergo surgery in order to insert plates and screws into his leg, find and treat injuries to cartilage, and fix ligament damage if it is present. She also says that he should take time to heal, noting that he will likely not return to basketball for another 4 to 6 months. We're here with Mrs. Stott, and what are the long-term impacts of an ankle break?
Hi. So it's not so much the damage to the bone that would be problematic in an ankle break. It would be more the damage to the tendons and the ligaments that support the ankle. So the ankle is really hard to mobilize, and it's also you put a lot of pressure and weight on it. So once you've damaged and torn ligaments and tendons around the ankle, the scar tissue there makes it more vulnerable, makes those tissues more vulnerable to re-tearing. Whereas the bone will heal and the scar tissue in the bone will actually be pretty stable. But the scar tissue in the tendons and ligaments makes the ankle much more vulnerable to rocking and more vulnerable to being retorn. And the kinds of things that might happen is if you are on an unstable surface like climbing rocks or something like that, it's much more likely that because there's more rocking now, you're going to re-tear, re-break the ankle in long term.
Thank you so much, Mrs. Stott. Back to you guys in the studio.
Well, now we know all about Gordon Hayward's injury. Catch us next time in Bristol, Connecticut on Sports Science by the ESPN.